So for this we've got two masses, 6 kg and 12 kg. They're attached as in diagram. The coefficient of friction is 1/6. We want to find the common acceleration and the tension in the string. I'll just label the masses. Not yet. So this one here is the 6 kg and this one here is 12 kg. Now to find the common acceleration and the tension in the string. Well, first off we need to work out, we're given that the tan of A is 4/3. Now whenever we see that, we should understand we can construct a simple right angle triangle. If that's A, opposite is 4, adjacent is 3, you can use Pythagoras' theorem and the hypotenuse works out to be 5. So if you're given tan A is equal to 4/3, you know that cos A is equal to adjacent over 3/5 and sine A is equal to 4/5, opposite over hypotenuse. So now that we can work that, we'll be able to work out the components of acceleration that work down the plane. So we've got this one here. First force we'll fill in is mg, the force of gravity down this way. This can be resolved into two, one along the plane like this and one down like this. Likewise for the 12 kg we've got gravity which goes down. This can be resolved into two forces, one which goes straight down the plane and one which goes into the plane like that. Now let's see, maybe I'll draw the triangles like this to make a little bit better sense. Like that there, into the plane, and then like that there. So I can label, I know if this angle is A, this angle here is also A, and this angle here is also A. Now the next thing that we can fill in is the component acting directly into the surface. So it's the adjacent side of this. So it'll be the magnitude, so this is the total magnitude is 6g. The total magnitude of this one is 12g. So the adjacent component is the magnitude, which is 6g, multiplied by the cos of the angle cos A, which would be 6g times 3/5. The component going down the plane, it's this vector here, and it works out to be the magnitude 6g times the sine of A, which in this case is 6g, sine of A is 4/5. Similarly for this one, we'd have the component acting directly into the plane would be, in this case, just double that, 12g times 3/5, and the component acting straight down is that one there, which would be 12g, and the sine of the angle, which would be 4/5. And this isn't particularly clear, but I'll just carry on as we are. I might just use a different colour for our arrows, for our points. Now there's also going to be a force of friction. Now you have to figure out first off, which way is the system going to go? Well, you know that it's generally going to move in this direction here, and this block will move up in this direction here. We'll know that there'll be tension in both of our blocks as well, one this way, one this way. We also know that there's going to be force of friction resisting motion, so that'll be there for this one, and it's going to be moving this way, so it's going to be in this direction for this one. So I might just label them in red. That's tension there. This is the resultant force, so this will be the mass times acceleration, which will be 6a. This here will be 12a. This will be the friction, that'll be the tension along that way. And now we've pretty much got most of our forces that we need to do. So if we deal with this first block here, the 6 kg block, we know that the resultant force, ma, will be equal to the tension minus the friction for A. Okay, now to work out friction, I might even call it a little bit different. I might just go lowercase f. So friction that A will experience. Now friction is always given by the resultant times the coefficient of static friction. So MA, which is 6A, is equal to the tension minus the resultant times the coefficient of static friction. The resultant comes from, it's the exact opposite of the component directly into the surface. So in this case, it's 6G times 3 over 5. 6G times 3 over 5. I could have multiplied that out, and then just multiply by the static coefficient, which is 1 over 6. So we get this value here is 6A is equal to T minus the 6's cancel, 3 over 5G. Now, the next block. So that's our first equation. 2 unknowns and G. We have to do the exact same for this one here. Again, the overall force, the resultant force, MA, in this case, is going to be equal to, I've left out a force here actually. Force of gravity should be in there as well. So I've got the tension going that way, friction is there, and then you've got this force, the component force acting down this way here. So I'll just add that in green. So it's tension minus the force of friction, and it's going to be also minus the Y component, the component acting down the incline here, which is 6G times 4 over 5. So it'll be 24 over 5G. And that should be included there. Minus 24 over 5G. And I can get rid of this one here. So minus 3 over 5G minus 24 over 5G will give us minus 27 over 5G. Now MA for this one is, I'll just move everything over a little bit. For this one, we know the forces that are acting up are, we've got this force here, which is going to be the maximum, which is going to be, that's the force, the larger force. It's going to bring the 12G times 4 over 5. Could multiply that in, but I won't bother just yet. And this is going to be minus the tension and minus the friction of B, the second body. So mass in this case we know is 12A is equal to 12 times 4, might as well put it in, 48G over 5. Minus tension, which we don't know, minus the frictional force of B. Again, we have to think about, we know this, the force component into the plane is this here, 12 times 3 over 5G, which is, so this would be minus 12 times 3 is 36 over 5G, multiplied by the coefficient of static friction, which is 1 over 6. So for this one we get 12A is equal to 48 over 5G minus T. 6 is cancelled there, and we have minus 6 over 5G. So we get 12A is equal to 48 over 5G minus, well, I can take that 6 from it, from the 48, so this component here and that component there will give us 42 over 5G minus T. Okay, so now it's just a matter of substituting in to find out, to work out which of them we have to find T and A in terms of G. Easiest way to do this probably is maybe simultaneous equations. So if I write the first equation there, 6A is equal to T minus 27 over 5G. It's our first equation. This equation, the second equation, that's number 1. The second equation I'll do in green is 12A is equal to, and I'll just bring the minus T out to the front, plus 42 over 5G. Now, adding these, you get 18A plus T minus T, they cancel, so we've got rid of them. 27 from 42 is 5, carry the 1, 15 over 5G. So 18A will be equal to 3G, or A will be equal to, divide both sides by 3 and then divide across, G over 6. So if we know what A is, then we can sub it into either of the two equations. I'll probably pick equation 1, which is 6A is equal to T minus 27 over 5G. Sub that in there. We have 6 times g over 6 is equal to t minus 25 over 5, which is just 5. Is that right? It's 27, sorry. 27 over 5g. So we have g, we add that to both sides, we get, and those cancel there, and we get t is equal to g plus that, which would be 32 over 5g, which is equal to whatever. You could leave it as that actually. Okay, so that's it.